Have you ever felt like this? Or this? Or on some really bad days, like this? Have you ever asked yourself, what do I need to do to score? Well, you're in luck. Because of the free kick. During soccer, after a player is fouled, the player is awarded a free kick. This free kick allows the player to take a free shot on goal. Our question is, what is the perfect angle to take this free kick at? The ball is placed at the precise location of where the foul occurred. The goalie stands ready, and the shot is taken. What we determined from our statistics is that when I, shooting from 30 yards out on a goal that is 8 feet tall, could put the ball into the back of the net in 1.23 seconds. In order to set up our equation accurately, we must assume that our acceleration is constant, that my shot is precisely accurate, not missing to the left or the right of the goal. So let's start with what we know. We know that I am shooting from 30 yards out, that the height of the goal is 8 feet, that it takes me an average of 1.23 seconds in order to kick the ball into the back of the net. From this information, we can create a triangle with a height of 8 feet, the distance is 30 yards, and an angle theta. Unfortunately though, 8 feet doesn't help us. We have to convert that to yards. Silly Mike. And our result, after using Traintrack's conversion factors, becomes 2.67 yards. Well, at least I think so. Now that we have our triangle back on scale, we can start creating an equation for theta. In this case, our theta is equal to the arctan of 2.67 yards over 30 yards. The yards cancel, and we get a result of 5.09 degrees. Unfortunately for us, that is not the theta that we're looking for, because it doesn't take into account the delta y. So now it's time to construct a new triangle with an angle theta, which is the same theta that we found before, a y-axis of the initial velocity of y, a hypotenuse of v naught, and an x-axis of x's velocity. Finding vx is easy. Just take the distance traveled and divide it by the time. In this case, our vx axis is going to be 30, our yards out from goal, divided by 1.23 seconds. Unfortunately for Mike doesn't know significant digits. He should have written 30.0 yards, but whatever. Our final value is 24.4 yards per second. Now comes the tricky part, finding VYI. To do this, we're going to have to take the tangent of our theta and multiply it by the v of x that we just found. Ergo, 24.4 times tangent 5.09 degrees. Therefore, our VYI is equal to 2.17 yards per second. Now that we have our VYI, we have to construct a new triangle. Isn't this getting annoying? This new triangle is going to take the VYI, which we just found, and our original time, 1.23 seconds, into account when finding the Y value. We multiply the two together to find the Y value, and wouldn't you know it, it equals 2.67 yards. We call this 2.67 yards that we just found the delta Y. Now in order to find the entire Y value for this triangle, we have to add delta Y to our original measurement, which was 8 feet, or 2.67 yards. Ergo, 2.67 plus 2.67. Our X value is also taken from the original information, which was 30 yards. Now, to find theta prime, which was our ultimate goal. We find theta prime using the equation that we used to find theta in the first triangle, which is the Y value, 2.67 plus 2.67, over 30. Then, we take the arctan of this value, and shaboom, we get 10.1 degrees. Yes, we did. Therefore, the perfect angle that I have to kick it at in order to score a goal would be 10.1 degrees up in the air. Who would have thought? Now here's a video of Ignacio trying to do a rainbow.